Cauchy-Riemann equation in Cartesian form statement is the necessary condition that the function w equal to f of z is equal to u plus iv is said to be analytic function. Then there exist four first order partial derivatives which are dou u by dou v, dou u by dou y, dou v by dou x, dou v by dou y, such that dou u by dou x is equal to dou v by dou y and dou v by dou x is equal to minus dou u by dou y, or ux equal to vy and vx equal to minus uy. This is the statement. So basically, for a function to be analytic, first four order partial derivatives, these derivatives must exist, then only we call it as an analytic function, such that they give one more condition as well. Dou u by dou x equal to dou v by dou y and dou v by dou x equal to minus dou u by dou y. Proof. Let w equal to f of z. Since f of z is equal to w is analytic at z equal to x plus y, iy. This is proven long back. Okay. So take w equal to u plus iv and z equal to x plus iy. Both are complex numbers. Substitute in place of w and z those respective values. That is, for w you have to substitute u plus iv and for z you have to substitute x plus iy. Take it as an equation 1. Differentiate partially with respect to x for equation 1. Only wherever the x terms are there, that only you have got to differentiate. So dou u by dou x plus I into dou v by dou x is equal to f will become f dash x plus iy. For x, what is the derivation? It is 1, right? Differentiation is 1. Take it as equation 2. We are not going to bother about this y because there is no x terms here. Next is differentiate partially with respect to y for equation 2. Now it's not for equation 2, it is for equation 1 itself. Okay, make these changes. It is 1. Dou u by dou y plus I into dou v by dou y is equal to f will become f dash x plus iy. Now we are doing with respect to y. So what is the coefficient of y? It is I. So multiply I. Okay. Take it as equation 3. Now using equation 2 in 3. For this third equation, you will put this equation because you have f dash of x plus iy. For this x plus iy, the whole thing you can substitute here. Okay. Next, dou u by dou y plus I into dou v by dou y is equal to, all these values you can put over here. It is dou u by dou x plus I into dou v by dou y. I value, bring it down. Okay. Next, dou u by dou y plus I into dou v by dou y is equal to, multiply I terms for the both the components. That will become I into dou u by dou x. What is I into I? I square is minus 1. We do have. So plus will become minus 1 dou v by dou x. Then you have to equate wherever the real part and imaginary parts are there. Wherever I is there, take it as one group, and take it other one you have to take it as another group. That will become dou u by dou y is equal to minus dou v by dou x, and dou u by dou x is equal to plus dou v by dou y. Uy equal to minus vx and ux is equal to vy. Therefore ux equal to vy and vx equal to minus uy are the required equation.